So, in the previous classes, we have talked about the development of agile software. Yeah, especially we have talked about the extreme programming, which is the best known and most widely used agile method. And later we have talked about the sprint. Eh? Yeah, the management of agile project, and we have said that the Scrum process is a well-known approach to manage agile project. And in the Scrum process, it is in this general agile method, we have concentrated on the sprint cycle. And now we'll concentrate on scaling agile methods. Agile methods have proved to be successful for small and medium-sized projects that can be developed by a small co-located team. This point we have talked about it before too. We said for small and medium-sized projects, we can prefer agile methods, while for large-sized projects, we may better use plan-driven methods. It is sometimes argued that the success of these methods comes because of improved communications, which is possible when everyone is working together. That means, as for agile methods, usually we sit together to develop the project, the system together. And some people say that the reason of the successful of agile methods is due to this one. And when we are together, we can have better communications. Scaling up agile methods involves changing these to cope with larger, longer projects where there are multiple development teams, perhaps working in different locations. As the title implies here, scaling agile methods. So when we want to scaling these agile methods, it means we will, instead of for small and medium-sized projects, we may work with larger, longer projects, and we may have multiple development teams, or even we may work in different locations. Here are some basic information about scaling agile methods. And we see that large systems are usually collections of separate communicating systems where separate teams develop each system. And frequently, these teams are working in different places, sometimes in different time zones. Like us now, we work in different time zones, but we cannot call us large systems, even though we are in different places, and but for the development of large systems, it may be this situation. We may work really at distance, with long distance. Large systems are brownfield systems they include and interact with a number of existing systems. Many of the system requirements are concerned with this interaction, and so don't really lend themselves to flexibility and incremental development. You see, it's quite different from our agile methods. Here, for large systems, many requirements are concerned with the interaction with a number of existing systems, and we cannot be very flexible, and we cannot release. Yeah, we cannot plan for several releases rapidly. And where several systems are integrated to create a system, a significant fraction of the development is concerned with system configuration rather than original code development. For large systems, we integrate different components to create an integrated system. And the code development is not so intensive as in agile methods. It's strange. Okay. In fact, large software system development is quite different from small system development. We can see they are different in these ways. The first one, large systems and their development processes are often constrained by external rules and regulations, limiting the way that they can be developed. You see, when the systems are large, and we may have external rules and regulations. So it's in traditional views, it's better to plan everything ready before developing it. The second difference between large and small system development is that large systems have a long procurement and development time. We see that it's difficult to maintain coherent teams who know about the system over that period, because during long period of time, people may move on to other jobs and projects. But for small system development, normally we can, as it may in a shorter period, we may keep the same staffs. Yeah, and the first point, as we have many external rules and regulations, perhaps we will require different types of system documentation. And documentation for agile methods, it's not so as important as in plan-driven methods. And the third difference is that large systems usually have a diverse set of stakeholders. It is practically impossible to involve all of these different stakeholders in the development process. Yeah. For example, for a medical system, we may have different.
Sorry to interrupt you.
Yeah. Here, for a medical system, end users or stakeholders may be nurses or administrators. And we may also have senior medical staff like hospital managers. All these different stakeholders or end users, they may have different requirements. So for large systems, it's quite we have a diverse set of stakeholders. That means perhaps we may have a diverse set of requirements. But for small system development. It's rather, the requirements or other things may be concentrate. And we have two perspectives of scaling agile methods. We call them scaling up and scaling out and scaling up. According to these, the names of these two perspectives, what can you guess? Oh, I will give you some notions later. You can say your opinion. Here, scaling up is concerned with using agile methods for developing large software systems that cannot be developed by a small team. And scaling out is concerned with how agile methods can be introduced across a large organization with many years of software development experience. So how do you understand these two different perspectives? Do you have some propositions? Some ideas about these two different perspectives? Any propositions for these two different perspectives? Scaling up and scaling out. Roy has said scaling up can be used for, say, to make a game. Scaling up, make a game, and scaling out. In fact, when I see these two, scaling out can be used to make a, say, commercial payment system. You have given some examples of these two perspectives. In fact, I was confused by these two perspectives at first too. And when I think it over, I think that these two perspectives are from different, are some cultural opinions. Like scaling up, it's an expansion of agile methods. You see here, it is concerned with using agile methods for developing large software systems that cannot be developed by a small team, because usually agile methods are for developing small or medium software systems, but we extend this method with larger scale to large software systems. I think, this is the perspective of scaling up. And for scaling out, it's more like the concept, how agile methods can be introduced across a large organization with many years of software development experience. That means how we can transfer or how we can leave this idea out, or we can diffuse this idea to large organization who normally use plan-driven or other traditional methods for large organizations. Is it clear for with this explanation? I have searched some documents to give to summarize this difference between these two perspectives. And with this explanation, is it clear for you? The difference between these two perspectives. The first one is to extend or expand the method. Traditionally, our company will use to make a payment system. Yeah. I think Roy, you are right too. Yeah, and for scaling out is how to throw out or diffuse this concept in some traditional companies, or in some traditionally a company who use plan driven, how we can diffuse this concept. Okay, this is the difference between these two perspectives. Now we'll see when scaling agile methods, it is essential to maintain agile fundamentals. As scaling agile methods, it's also agile methods, so we should keep the fundamentals like flexible planning, frequent system releases, continuous integration, test-driven development, and good team communications. Yeah, these fundamentals, we have seen them for several times, the good practices, etc. Now we'll see scaling up to large systems. Yeah, I think, Roy, you are right too. We see the even for the objectives of these two perspectives, scaling up is for some systems and scaling out normally is for some organizations. Yeah, across some organizations. Here, scaling up to large systems. For large systems development, it is not possible to focus only on the code of the system. We need to do more upfront design and system documentation. Yeah, these are the critical adaptations. You see, the software architecture has to be designed and there has to be documentation produced to describe critical aspects of the system for large systems. For example, database schemes, the work breakdown across teams, etc. So we need to adapt this require of large systems when we use the scaling agile method. And second adaptations may be that cross-team communication mechanisms have to be designed and used. This should involve regular phone and video conferences between team members and frequent short electronic meetings where teams update each other on progress. As we said, for agile methods, most of the time, the team, the developer, the whole team maybe sit together and have some short meetings. We can be face to face, but for a large system, this may be different. So we have to consider different communication channels as emails or social networking systems. We should provide different communication ways to facilitate the communications. It's important, cross-team communication. And the third adaptation should be the continuous integration, where the whole system is built every time any developer checks in a change. This integration is practically impossible. However, it is essential to maintain frequent system builds and regular releases of the system. We see that for large systems, usually we need several separate programs. We need to integrate these different parts of programs to create the system. And this may mean that new configuration management tools that support multi-team software development have to be introduced for large systems. It is difficult. In fact, it is also difficult to introduce agile methods to large companies. Here we have several reasons. The first one is that project managers who do not have experience of agile methods may be reluctant to accept the risk of a new approach. We see that for project managers, usually they have their own experience of their own habitude methods. So for them, agile methods are not their usual method. So perhaps they will not want to have the risk of a new approach because they don't know how this new method will affect their particular projects. Second reason is that large organizations often have quality procedures and standards that all projects are expected to follow. As we have said that in large organizations, maybe we can say they have more bureaucratic nature, and these are likely to be incompatible with agile methods. As we know, for agile methods, we have less documentation. We concentrate more on the process of development. And agile methods seem to work best when team members have a relatively high skill level. However, within large organizations, there are likely to be a wide range of skills and abilities. Here, this property, we have talked about it before too. For agile methods, as there may have flexible tasks for programmers. So normally, we need members to have high skill level. But in a large organization, we may have different levels of programming or algorithm, different things. People with lower skill levels in this situation may not be effective team members for agile processes. Another reason is that there may be cultural resistance to agile methods, especially in those organizations that have a long history of using conventional systems engineering processes. I think that this is it's normal because even not just for companies or what, even for personal daily life, we have some cultural resistance. We don't want to change our habitude that lasts a long time. So for organizations who have long history of using other processes, it may be difficult for them to accept the idea of agile methods. So here we see that scaling agile methods, we have its necessaries in some situations, but we have two ways to scaling agile methods, scaling up and scaling out, these two perspectives, but both perspectives are difficult with different reasons. So this is for this part, scaling agile methods. And we see in here. For now, we have said that a particular strength of extreme programming is the development of automated tests before a program feature is created. And all tests must successfully execute when an increment is integrated into our system. That means for extreme programming, as we have said last week, we have different versions of the system in a short period. But each version of the system, when we add some function there, we need to do the test before. It is a test first approach. And we have talked about the Scrum method. It is an agile method that provides a project management framework to manage a project using agile methods. It is centered around a set of sprints. It's the cycle of sprints. And there, we have fixed time periods when our system increment is developed. And scaling agile methods for large systems is difficult, as large systems need upfront design and some documentation. So usually we say agile methods are appropriate for small and medium systems. Okay, this is this method, this chapter, the development of agile methods. Now we'll continue with the fourth chapter. The fourth chapter is about the requirements engineering. The objective of this chapter is to introduce software requirements and to discuss processes involved in discovering and documenting these requirements. Normally, after reading this chapter, we will understand the concepts of user and system requirements and why these requirements should be written in different ways. We should understand the differences between functional and non-functional software requirements. Functional and non-functional are two types of software requirements. We'll discuss it further. We'll see how requirements may be organized in a software requirements document, and we'll try to find out the principal requirements engineering activities of elicitation, analysis, and validation, and the relationships between these activities. Also, we will understand why requirements management is necessary and how it supports other requirements engineering activities. So, precisely in this chapter, we'll cover these topics. The first one is the functional and non-functional requirements. The second one is the software requirements document. And later are some requirements for different activities. For example, requirement specification for the engineering processes, for the elicitation and analysis, the validation and management. As we know, the requirements for a system are the description of what the system should do. We can say that the process of establishing the services that the customer requires from a system and the constraints under which it operates and is developed. Here is the definition of the requirements engineering. And the requirements themselves are the description of the system services and constraints that are generated during the requirements engineering process. These requirements, in fact, they reflect the needs of customers for a system that serves a certain purpose, like how to control a device, how to place an order, or how to find information. And thus, the process of finding out, analyzing, documenting, and checking these services and constraints, we call this process requirements engineering, the title. In some cases, a requirement is simply a high-level abstract statement of a service that a system should provide or a constraint on the system. But at another extreme, the requirement is maybe a detailed formal definition of a system function. So we may separate requirements by the level of the requirement. One type is the user requirements. User requirements is, we can call it statements in a natural language, plus diagrams of the services the system provides and its operational constraints. It is always written for customers. We see here, as it's for customers, we use usually a natural language plus diagrams because it's it is to facilitate the communication with the customers. And we describe what services the system is expected to provide to system users and the constraints under which it must operate. That's why we say user requirements. We use this term to mean high-level abstract requirements. And the second type of requirement is the system requirements. System requirements are a structured document setting out detailed descriptions of the system's functions, services, and operational constraints. Here we define what should be implemented, so may be part of a contract between client and a contractor. Here we have more detailed descriptions of the system software's functions, services, and operational constraints. And we should define exactly what is to be implemented. These system requirements may be part of the contract between system buyers and the software developers. That is also why we say that system requirements means the detailed description of what the system should do. Okay, we'll have a break of 10 minutes if you want. And we had our break, and now we'll continue. Just then we have talked about the two types of requirements. We say we have classified these two types of requirements by different level of abstract. For user requirements, it's always for some high-level abstract requirements, and system requirements refer to the detailed description of what the system should do. And normally, different levels of requirements are useful because they communicate information about the system to different types of reader. As we have said here, user requirements are for customers and system requirements, for developers, and it can serve as a contract between system buyers and software developers. Now we'll see an example here. This figure illustrates the distinction between user requirements and system requirements. This example comes from a mental health care patient management system. Yeah, we have talked about this case use in the first chapter. Yeah, here the user requirements, and we say this system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. And for system requirements, we have some detailed functions. The first one, on the last working day of each month, a summary of the drugs prescribed, their cost, and the prescribing clinics shall be generated. The system shall automatically generate the report for printing after on the last working day of the month. Yeah, etc. We see that with one user requirement, we can expand it into several system requirements. And here, the user requirement is quite general. For system requirements, they provide more specific information about the services and functions of the system that is to be implemented. You see, really, users' requirements and system requirements are quite different. And we need to write requirements at different levels of detail because different readers use them in different ways. Yeah, as we say, user requirements for customers and system requirements for developers, and they can serve as the contract between system buyers and developers. Here, this figure shows possible readers of different types of requirements specification. Here are some readers for user requirements and readers for system requirements. The readers of the user requirements are usually concerned with how the system will be implemented, and there may be managers who are not interested in the detailed facilities of the system. Yeah, system end users, client engineers, contractor managers, system architects. But for system requirements, the users are system end users, client engineers, system architects, software developers. Here, these readers need to know more precisely what the system will do because they are concerned with how it will support the business process, and because they are also strongly involved in the system implementation. That's why we need to write requirements at different levels of detail. Yeah, we have another way to classify software system requirements. We can classify them as functional requirements and non-functional requirements. Functional requirements are statements of services the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. Also, it may state what the system should not do And non-functional requirements are constraints on the services or functions offered by the system. They may include time constraints, constraints on the development process, standards, etc. And non-functional requirements often apply to the system as a whole rather than individual features or services. Yeah. Here we see that for functional requirements, we talk about the services and how the system will react to particular inputs and how the system behave in particular situations. So we see that the notion here, we consider the system normally as an integrated, an integrated system. We may also state what the system should not do, but for non-functional requirements, we have some functions or some precise requirements like timing constraints on the development process, the process capability, etc. In fact, the distinction between different types of requirements is not as clear-cut as these simple definitions suggest. We'll see these two types of requirements in detail. For the functional requirements, we describe what the system should do. We describe the functionality or system services. And these requirements depend on the type of software, expected users, and the type of software being used. Functional user requirements may be high-level statements of what the system should do. Like our user requirements. And one expressed as user requirements. Functional requirements are usually described in an abstract way that can be understood by system users. It is the general approach taken by the organization when writing requirements. So we should describe the system services in detail. However, more specific functional system requirements describe the system functions, its inputs and outputs, etc. in detail. So it's not just the user requirements. We may also include some system requirements in functional requirements. Here, a user shall be able to search the appointment lists for all clinics. Here is an example of functional requirements for the system we have seen before. And we see that the system should generate each day for each clinic a list of patients who are expected to attend appointments that day. Each staff member using the system shall be uniquely identified by his or her 8-digit employee number. We see these 3 functional requirements for the system. They may vary from very general requirements covering what the system should do to very specific requirements reflecting local ways of working or an organization's existing systems. Here, we see we use these functional requirements to maintain information about patients receiving treatment for mental health problems. And these requirements define specific facilities to be provided by the system. Yeah, as we say, the first functional requirements is very general. A user shall be able to search the appointments list for all clinics. Here, a user can be different types. User may be the patient, maybe the doctors, maybe nurses, etc. And the appointments lists, it may be it may be the appointments list of one patient or the appointments list of clinics. So we have several different comprehensions about these requirements. But other requirements, the second one and the third one, they are more precise. Is it clear for you?
Yes, ma'am.
Okay, thank you. These are the functional, an example
Yes,
of functional requirements for this system. And we see with the first requirements is very general, and we can say it's imprecise. And this impression may cause some problems. As we say, problems arise when requirements are not precisely stated. Imprecision in the requirement specification may be the cause of many software engineering problems. Ambiguous requirements may be interpreted in different ways by developers and users. Yeah, for us, it is natural for a system developer to interpret an ambiguous requirement in a way that simplifies the implementation. Often, however, this is not what the customer wants. So new requirements have to be established and changes made to the system. Of course, with these new requirements and these changes, all these things may delay system delivery and increase costs. Yeah, as we have said here, for the first requirements, okay, here we concentrate on the term search. For the user intention, it may be we search for a patient name across all appointments in all clinics. And for a developer, perhaps we'll interpret it like we search for a patient name in an individual clinic. User chooses clinic, then search. You see here, it's quite different. The rationale for this requirement is that patients with mental health problems are sometimes confused, and they may have an appointment at one clinic, but actually go to a different clinic. If they have an appointment, they will be recorded as having attended irrespective of the clinic. And the medical staff members specifying this may expect search to mean that given a patient name, the system looks for that name in all appointments at all clinics. However, these requirements are not explicit in the requirement. And for us, system developers, we may interpret the requirement in a quite different way, and we may implement a search so that the user has to choose a clinic, then carry out the search. This obviously will involve more user input and so take longer. You see, we create rather big problems if we don't precise the requirements. In principle, requirements should be both complete and consistent. When we talk about completeness, It means they should include descriptions of all facilities required. That means all services required by the user should be defined in the requirements. And for consistent, there should be no conflicts or contradictions in the descriptions of the system facilities. Requirements should not have contradictory definitions. So we need to keep the requirements complete and consistent. In practice, it is impossible to produce a complete and consistent requirements document, especially for large, complex systems. We may have several reasons for this, for this phenomena. One reason is that it is easy to make mistakes and omissions. Perhaps we'll forget something when we write specifications for complex systems. Another reason is that there are many stakeholders in a large system. As we have said before, the end users may be composed by different people. And a stakeholder is a person or role that is affected by the system in some way. Each stakeholder may have different and often inconsistent needs. Their requirements may be quite different. And this inconsistency of requirements may not be obvious when the requirements are first specified. So these inconsistent requirements are included in the specification. And these problems may only emerge after deeper analysis or after the system has been delivered to the customer. That's why, in practice, it is impossible to produce a complete and consistent requirements document, especially for large, complex systems at first. So after seeing the functional requirements, now we'll concentrate on the non-functional requirements. Non-functional requirements, as the name suggests, are requirements that are not directly concerned with the specific services delivered by the system to its user. And these requirements may define system properties and constraints. For example, reliability response time and storage requirements. Constraints are, for example, input-output device capability, system representation, etc. So, non-functional requirements may relate to emergent system properties, and they may define constraints on the system implementation. And process requirements may also be specified, mandating a particular integrated development environment, programming language, or development method. Non-functional requirements may be more critical than functional requirements. If these are not met, the system may be useless. It means that system users can usually find ways to work around a system function that doesn't really meet their needs. Even though perhaps the system works not as we want, but at least it works. However, failing to meet a non-functional requirement can mean that the whole system is unusable. We cannot use it at all. For example, if an aircraft system does not meet its reliability requirements, then it will not be certified as safe for operation. In this way, we may not able to start it. Non-functional requirements may affect the overall architecture of a system rather than the individual components. It is often more difficult to relate components to non-functional requirements, and the implementation of these requirements may be diffused throughout the system. We have two reasons for this. Yeah, this is the first reason that the implementation of these requirements may be diffused throughout the system. As we say, these requirements may affect the overall architecture, not just the individual components. For example, to ensure that performance requirements are met, we may have to organize the system to minimize communications between components. And the second reason is that a single non-functional requirements, such as a security requirement, may generate a number of related functional requirements that define system services that are required. In addition, it may also generate requirements that restrict existing requirements. So, non-functional requirements arise through user needs because of constraints, organizational policies, the need for interoperability with other software or hardware systems, or external factors such as safety regulations or privacy legislation. This figure is a classification of non-functional requirements. From this diagram, we can see that the non-functional requirements may come from required characteristics of the software, the product requirements, the organization developing the software, organizational requirements, or from external sources. We call external requirements.
Ma'am.
Yeah.
Like, what is the meaning of organizational requirements? Like, suppose organization in the sense like the developer or the buyer.
It's for the developer. Yeah, we'll talk about it in detail later. Yeah. Now.
Okay.
Yeah. Thank you for your question, Shibli. Here.
Well,
as we say, we can classify we can classify the non-functional requirements into these three types. For the product requirements, these requirements specify or constrain the behavior of the software. Examples include performance requirements on how fast the system must execute and how much memory it requires, space requirements. Also, we may have the security requirements, usability requirements, and dependability requirements. For organizational requirements, as Shibli asked, these requirements are broad system requirements derived from policies and procedures in the customers and developers organization. So, in fact, it's for these two parts, for the customers organization and the developers organization. Here we may have the example include operational requirements that define how the system will be used, development requirements that specify the programming language, and the development environment or process standards to be used, and environmental requirements that specify the operating environment of the system. Yeah, is it clear?
Clear, ma'am.
Okay, thank you. Yeah, that's for the organizational requirements. And for the external requirements, this one, it covers all requirements that are derived from factors external to the system and its development process. This may include regulatory requirements that set out what must be done for the system to be approved. For use by a regulator, such as a bank or something else. We have also legislative requirements that must be followed to ensure that the system operates within the law. We have also some ethical requirements that ensure that the system will be acceptable to its users and the general public. Yeah, these are for external requirements. Yeah, and this part is for for 3 types of non-functional requirements. And we have a summary of these 3 types here. For the product requirements, we specify that the delivered product must behave in a particular way, like execution speed, reliability, etc. And for the organizational requirements, there are a sequence of organizational policies and procedures like process standards used, implementation requirements, etc. And for external requirements, they arise from factors which are external to the system and its development process, like interoperability requirements, legislative requirements, etc. Now, these are the 3 different types of non-functional classification. Here, we have an example of non-functional requirements for the same system, medical system. Here we have the product, organizational, and external requirements. Yeah, we have already seen their user requirements before. We see here the product requirement is an availability requirement that defines when the system has to be available and the allowed downtime each day. It says nothing about the functionality of the system, and it clearly identifies a constraint that has to be considered by the system designers. This is the product requirement. And the organizational requirement specifies how users authenticate themselves to the system. The health authority that operates the system is moving to a standard authentication procedure for all software, where instead of users having a login name, they swipe their identity card through a reader to identify themselves. And the external requirement is derived from the need for the system to conform to privacy legislation. And as we know, privacy is obviously a very important issue in healthcare systems. And the requirement specifies that the system should be developed in accordance with a national privacy standard here. In fact, a common problem with non-functional requirements is that users or customers often propose these requirements as general goals, such as ease of use, the ability of the system to recover from failure, or rapid user response. In fact, goals are set out good intentions but cause problems for system developers, as they leave scope for interpretation and subsequent dispute once the system is delivered. So non-functional requirements may be very difficult to state precisely, and imprecise requirements may be difficult to verify. Yeah, we may have a general goal as a general intention of the user, such as ease of use. We may have verifiable non-functional requirement, as we here what is noted, a statement using some measure that can be objectively tested. So these goals are helpful to developers as they convey the intentions of the system users, but it's better to state these goals precisely. As we have said, the goal in the system. We say the system should be easy to use by medical staff and should be organized in such a way that user errors are minimized. Here, this goal is very, very general. It's we may rewrite this goal to show how the goal can be expressed as a testable, non-functional requirement. Perhaps it is impossible to objectively verify the system goal, but in some description, we can at least include software instrumentation to count the errors made by users when we test the system. For example, here, we may change this general goal into this one. Medical staff shall be able to use all the system functions after 4 hours of training. Here we have something to quantify easy to use. After this training, the average number of errors made by experienced users shall not exceed 2 per hour of system use. Here, this part is to explain user errors are minimized. You see here we have changed this general goal into something that we can test. So we call it testable non-functional requirement. In fact, whenever possible, we should write non-functional requirements quantitatively so that we can objectively test these requirements. Here, this figure shows metrics that we can use to specify non-functional system properties. And we can measure these characteristics. We can measure this when the system is being tested to check whether or not the system has met its functional requirements. Is it, Chill here, do you have some questions? Some questions for this part?
No, ma'am, it's clear.
It's clear. Okay, so in this class, we have talked about the last section of the third chapter.
She asked for a question. He asked, what is the meaning of the goal?
Pardon?
I think Munshi asked a question. Munshi asked a question in the text.
Oh, goal. It's like the objective. I mean, thank you. And thank you, Shibli. Like objectives, purpose. Oh, yeah, objective. So, we cannot say purpose exactly. Like here. The goal. When an organization asks us to develop a system, they may say, we want this system that will be easy to use by my staffs, and we want the system can be organized so that we will make minimum errors possible. This may be the goals or objectives, the the original ideas of the customers. It's like this. And then the goal. And then for us, when we hear it, we don't know how we can define our system is easy to use or not. Perhaps, yeah, for different people have different criteria. We may say, yeah, for me it's easy to use, but for you it's not easy to use. So this is too qualitative. We cannot define it very clearly. Also here, minimum errors. Minimal errors. What does it mean? It means 10 errors per hour or one error per hour. Yeah, it may be very different. So we can precise or quantify these requirements into some testable requirements. Yeah. Okay. Thank you. So in this class, we have talked about the scaling agile methods and yeah, some requirements like functional and non-functional requirements. Yeah. So we'll stop here. So I wish you a good day and see you the day after tomorrow.